This is one of my favorite parts of this whole subtopic. It's learning the things that have changed between chimpanzees, or between the common ancestor that we shared with chimpanzees and the common and what we are today. So you can actually see in the human fossil record where we have come from and what traits we've evolved. So these are the major trends. So we did our timeline. Now we're going to talk, we did our timeline. Now we're going to talk about the trends. So there's a few things that we can look at. The major one we're going to look at is the fossil record, and then there's a really small video on molecular homology. So there's all of these things that we can look at in humans and other hominin ancestors to see what we've actually trended towards. We can look at our pelvis. We can look at our foot and our big toe arrangement. We can look at this guy here. This is really, really important, this foramen magnum. Yeah, we can also look at our teeth. We can look at our spine shape, our overall skeleton. So we can look at actually our arm to leg ratio. We can look at our femur. Yeah. So how long our femur is. And we can also look for the presence of any vestigial structures. And all of these structures are going to give us the evidence that we need. So to begin with, I'm going to start with the pelvis. So we are on page 6. And you can see 3 different pelvises here. So you can see the chimpanzee is long and thin, or long and narrow. So there's 2 things here. Its pelvis is long and thin, whereas ours is much shorter and broader. So the pelvis here is like long and thin. This one is much shorter and broader. Now what you can do with this one, this is where I have to try and, this is where I walk around, yeah, is you've got to pretend, and let's see if I can get myself on camera here. You've got to pretend like you've got really long skinny hips like this. They put you together and they kind of tilt you forward. Yeah, so your legs can only walk directly underneath what you're doing. Yeah, you can't swing out to the side. If you tilt your pelvis back a bit more, then we get this ability to kind of walk a bit wider. We can also move our hips side to side. This is a really unattractive view, but you're getting what I'm doing, yeah? So the wider your hips are, the better you are at walking upright. They actually support the whole upper part of your body. So this short and broad pelvis gives us the ability to hold our upper body. Pretty cool. In addition to that, you have a look at the difference between a chimpanzee's foot and a Homo sapiens foot. Homo sapiens foot has got this really nice long straight line down through it. That is what enables us to point our toe forward, and this means we walk forward. Chimpanzees kind of have these hand-like feet and they walk along. So we're looking at the trend, yeah? So our trend for bipedalism is that our pelvis starts to get shorter, yeah, so not as tall, and it also starts to get wider and broader, and that's so it can support my whole upper body. My big toe also begins to point forward, yeah? As my big toe points forward, my legs kind of come into play a little bit better. Here's another picture of some pelvises for you. All right, let's have a look at our skull. You can see really easily here the massive difference in size. Yeah, so the trend here is that we have an increase in size of our brain case. Yeah, so human skull or brain case has definitely increased in size over the past 4 million years. We've also flattened our face. So have a look at the chimpanzee's face. The chimpanzee's face is like this. Yeah, it kind of goes out. I'm going to hold my head straight, yeah? It kind of goes out like this. The jaw is out here. So this is a chimpanzee. Yeah? Whereas our face is decidedly more flat. Yeah, and what might be a benefit of that is that it allows my head to sit nice and straight on top of my shoulders. Also having a look at the difference in our teeth, because we don't quite have as much space. Yeah, we don't have as much space in our mouth, because when our jaws went from out here to back here, we lost all this space in our jaw. So our teeth had to get smaller. So our canines went from being huge like this to being very, very small down here. And you can see how much more space, even in Australopithecus, how much more space they had in their mouth for their teeth. All right. So the jaw is protruding. The other thing about the jaw is in a gorilla, and I will show you this. Here we go. In a gorilla or in a chimpanzee, even here is Australopithecus. This is more U-shaped. So it's more shaped like and I can't do this upside down, yeah? But if you turned it upside down, it would be more U-shaped. Whereas a modern human, we have more of a parabolic jaw. Yeah, so there's our difference. So our jaws are becoming more parabolic. Now, this is a really cool one. So these are the foramen magnum. So it's got a really cool name and it kind of reminds you of ice cream. And I don't know what foramen would remind you of, but maybe ramen for ramen noodle ice cream. There we go. Nothing to do with what I'm talking about. So this is the hole in which your spinal cord can get from your back into your brain. Yeah, because you want your brain to be able to communicate with the rest of your body. So to do that, it needs to be a hole. So what you will see in a Homo sapiens is we have what we call a very central foramen magnum. So this is on halfway down page 7. We have a very central foramen magnum. And the picture on your thing shows it really, really clearly. Whereas a chimpanzee or a gorilla, you can see even here, the gorillas is even more further back. The chimpanzee is in the middle there. So this is Australopithecus here. So as that foramen magnum moves to be more central, this is our trend. The foramen magnum moves to be more central or more towards the middle of the skull, the more recent or more kind of towards Homo sapiens we become. The next bit is our spine. So our spine has got this really cool ability to be S-shaped. And you can kind of feel that. You can feel that in your lower back right now. You should be able to push in here. You should be able to see that we've got an S shape. Now, if you, this S shape, here we go, let's see if I can diverge this. This S shape kind of pushes me forward like this. And what that means is it actually keeps my whole upper body much more upright. Think about it when you push your bum forward. Now, what I want you to do is I want you to straighten your back. So if you straighten your back all the way through to your hips, what do I start to do? I start to lean forward. Now, what might this mean? This might mean I walked on my hands. So if I had a completely flat back and longer arms, I would be walking around on my hands and my feet. Whereas if I have an S-shaped spine, I get to line all of my organs and everything up right on top of each other. Now, really good for walking upright, really bad for a lot of other things. So having a nice straight flat back like the gorilla meant that you didn't crush as many of your internal organs. The S-shaped spine isn't great for our internal organs, but the benefits have outweighed the negatives here. The next one is our femur, our leg bone. So our femur, the human femur is much more angled towards the knees, whereas chimps have much straighter legs. So when our knees come together, again, it means that we can balance on one leg much easier. If your leg was out to the side trying to balance, you would have to counterbalance like this. If your leg comes right underneath you, you can balance on one leg. Now what that means is that you can lift one foot and be standing on one foot and move to the other. Yeah, and this is how we walk. We never actually walk with both of our feet on the floor at the same time. So it's the fact that we have these knees that come in, or our femurs are angled inwards, that allow us to balance our torso when we're walking, and in particular when we're on one leg. So here's a really interesting kind of thing. You can look at the angle of different femurs. The other thing that I mentioned really briefly is that we have a vestigial structure that indicates that we probably came from a primate. Our coccyx, our tailbone, is a really good example of a vestigial structure that indicates that we probably once came from a common ancestor that had a tail. So here's a really nice diagram that can summarize the Australopithecines versus the chimpanzees. We get a more bowl-shaped pelvis. We get an S-shaped spine. We get a more central foramen magnum. We have a more parabolic shaped jaw. We have a flatter face. We have a larger brain case. What else do we have? We have an femur angled in. We've got a big toe that points forward. All of these are trends in human evolution. So I want you to pause and I want you to see, can you come up with, you can do it in pencil, that's not a problem. Can you come up with all of these different trends in hominin evolution? And in 3, 2, 1, I'm going to give you the answer. 3, 2, 3, 2, 1. Here we go. So there's a whole bunch here. You might want to pause and check your answers. There's also, this is what I was saying, early hominins versus late hominins. So our brain case gets bigger. Our foramen magnum gets more central. Our face gets flatter. Our jaw gets more parabolic. Our canines get more reduced. They get smaller. Our pelvis gets more shallow and bowl-shaped and tips because it indicates it can support our torso. Our femur angle gets more pronounced while we can hold our body on top of ourselves. Our spine shape gets more S-shaped. And our brow ridges, compared to the Australopithecines, even compared to the Neanderthals, much, much, much more reduced. There's also another picture just here if you want to practice and write anything else down. So the exam note I have for you is that you must remember at least 3 to 4 of them and be able to recognize the rest. But you should be able to recall at least 3 to 4 of you are given some different questions, and I'm going to go through those in another video.